Hey guys, I'm Nick Fett from Tellor, and I'm here to present you guys today a little bit on how to use Tellor. So for those of you guys that don't know, Tellor is a decentralized oracle built on Ethereum. A decentralized oracle, basically what we do is we allow you to get pricing information into your dApps. I know a lot of you might think like, well, do I even need an oracle in a project or for my company? And it's usually the first question that you want to ask yourself, because it's actually how I got into the issue. So before I was doing Tellor, we were actually building a derivatives protocol. So it was allowing you to bet on the price of Bitcoin or the price of US stocks or the price of gold. And whenever you're doing that, what happens is you run headfirst into the problem of, well, okay, well, who gets to say what the price of Bitcoin or the price of the S&P 500 or the price of gold is? And this is where you actually need an oracle. So if you know, in Ethereum smart contracts, they can't read APIs. They can't go talk to the internet. So usually somebody would need to put in the price of Bitcoin or gold. And this is a centralized point of failure. So in the case of the derivatives or a lot of financial products, usually the company is just the one who's sitting there, and they'll enter in the price. And the problem with this is that now if that company wants to say that the price of Bitcoin is $1 million, or if it's zero, they can really cause you to lose a whole lot of money. And I've given several talks in the past. You can feel free to go look those up, just on how much of DeFi is currently relying on a lot of these centralized feeds. And it's really a big problem in the space. So if you are building a project, make sure that you really think about the oracle problem through and through, and how you're getting this information on chain. Tellor, the way that Tellor works, we have a network of miners. So similar to Ethereum or Bitcoin, where they're solving some sort of meaningless proof of work computation, and they get to say what the valid block of transactions are. Tellor's miners, they solve some meaningless proof of work computation and then get to say what the price of a given asset is, say Bitcoin or gold. And that's how Tellor works. And this allows us to completely remove that central party. So without getting too much into the details of how it works, I'll post plenty of links up there. I'm just going to share with you guys today how to implement Tellor into your smart contracts. Obviously, if you guys have any sort of questions, feel free to use the chat. Myself and my team will just be kind of answering them for you as you place them in there. So thanks for listening, and I will get started. So first, I'll share our screen. So I'm going to do a dangerous thing here, and we're going to try and do a software demo. Just live. I'm going to code up a whole new repo, and we'll see if it works out. So first, we'll go into we'll create a repository. So we're just going to make a new. We'll call it Unitize, and CD into there, and then we'll do a truffle init. So truffle init is how you can start a project with Ethereum's truffle. And then, so we're good there. And then the first thing we're going to do, since it'll probably take a while, we're going to install using Tellor. So you're just going to do npm install using Tellor. Now, what I'm doing here, is I'm going through our documentation. So if you go to read the docs/Tellor, you can click on our latest here. And what you'll see, if you go integrate Tellor into your smart contracts, this is exactly what I'm just going to be walking through. So you can go follow along here if you don't want to listen to me talk. But it should be nice and easy, and we'll go through it here. So the first thing, basically, what are we going to build is the main question. And I think we should just, if for what most oracles are, we're just going to actually build, let's pull in a value and see whether or not it's greater than 100, just for a super simple thing. And for this, we actually have a whole sample repo up for pulling these things. So we'll go copy some code and then we'll walk through it. So we'll come here, this is just my IDE. And then what we'll do is we'll go into our Unitize folder. All right, so now that we're in our Unitize folder, we'll make a new contract. And so we don't have to do a whole lot of typing, because I know typing is like the worst thing to watch in code demos. We're just going to cut and paste the sample using Tellor, and then I'll walk you guys through it. So we're going to save it as, we'll call it the unitize.sol. All right, and then contract unitize.sol. So if you guys are semi-familiar with Ethereum smart contracts, this should look pretty standard. But the way that it works, so you got your pragma, and then what we're going to be doing is we're going to be importing the using Tellor package. So using Tellor, all that using Tellor is it exposes some of the getters in the Tellor contract, namely get data before and get current value. So it allows you to read Tellor values. So whenever you're starting the contract, here's your constructor, you have to pass it two things. You have to pass it a Tellor ID and the Tellor address. The Tellor address, as you all should know, is the contract address of Tellor on the given network. You have to know where you're querying. Shouldn't be too hard to figure out. And then the Tellor ID, this is the ID that corresponds to what asset you're querying. So ID 1 is ETH US dollar, ID 2 is Bitcoin US dollar. If you go back to the read the docs, you can go look, and there's a whole list of, I think we have 51 assets up currently that are supported, and you can go query all of those. So you have to know which specific one that you'll be querying, and you put that in. And then after you do that and you're running, then you have access to the using Tellor functions. Get current value, so it will look up the current value of Tellor ID. And it's going to, both of these return three things. Did get, this is a Boolean, so true or false if it did get it. The current value should be pretty easy. And then the timestamp. So how old the current value is. So, you know, if you're using a derivatives contract, you might want to make sure that the value that Tellor has is within a day old, or even within 10 minutes old. Just will all sort of depend on the application that you're building. And then get data before. This one's a little bit more complex, but the reason that you would want to do this is the way that Tellor works is whenever people place the information on chain, there's some time there where there isn't really a finality to Tellor values. And what this means is that it can be disputed. So let's say somebody places on chain and says the price of Bitcoin is $8 million. What will happen probably very quickly in the Tellor system is that somebody will come and they'll say, hey, that's wrong. They flag it, and that miner will actually get slashed. So the miners have to put up a bond that they can get slashed if they lie. And that value will get taken off chain. And so you would just wait for the next Bitcoin value to come up, which would likely be correct. So if you wanted this, how long you want to wait. So whenever you're running get data before, if you wait a whole day, it's had a lot longer for people to look at it and validate it in the network versus getting just a current value. Obviously, if you're doing it manually, like we're going to be doing here, you could just look at the value yourself and then go run it, since all the Tellor values are also on chain. Anyway, those are the two things that are available. And let's write here. What we're going to do is we're going to write a function, or we're going to check values. And this is going to be an external function. And what we're going to do is we're going to check whether or not we're going to update the values. I'm going to make this one public, one's external. And then what we're going to do is if current value is greater than 100. I'm going to return true. So external returns Boolean. And then we'll do else return false. Okay, so for readability. And this is going to be a really simple contract. Obviously, what you would do if you had a financial contract, say you could pull a start price, have it wait the day, pull an end price, and you can have some funds move. Or you can have a lending protocol that uses Tellor to figure out whether or not you're fully collateralized. There's a lot of different things you can do with just the ability to query a price without needing a central party to put it in. Happy to go into those use cases anytime. Anyway, so save this, and now we will compile it. Okay. Man. We're just gonna comment this out for now. And then we're not using it. There we go. We're good to go. Anyway, now we're going to move on. So this is really easy so far. Hopefully all of you guys are with me. Oh, I forgot we'll go back to the code real quick because this one came up on our last hackathon whenever they were like, what is this in the constructor function? So using Tellor, so contract is using Tellor. There's just a little bit of solidity for you guys. This actually inherits all of using Tellor. So this would be like pasting the using Tellor contract underneath this one. But it has a constructor argument as well. And it takes Tellor address. So you have this constructor, which you have here, but you need to pass this Tellor address into using Tellor. So that's all of it's doing. This is accessing the constructor arguments for using Tellor. That's good. The next piece is that you're going to need to do though, whenever you're starting up your favorite thing, you're going to need to run migrations and you're also going to need to test these things. So let's do those. Whenever we're running, back to our things. Here are, quick, as we just walked through before I forget, the main net address and the Rinkeby address are up here. So if you guys are wondering what Tellor addresses should I use, just look in the documentation. And then the migrations file, I actually have sample migrations file written for you guys. So you guys don't have to actually write anything. And we'll go here. What you want to do is just cut and paste it because you can have multiple migration files. So you'll come here, create a new one, save it as to Tellor migration, Tellor migration.js, JavaScript file. Okay. Okay. And then whenever you're migrating, if you're actually going to Rinkeby or mainnet, what you'll want to do is just use this. So you'll put in the Tellor address. Here's the one for Rinkeby, and it'll deploy your contract. And right now we're sample using Tellor, which we're going to have to change with the right functions. But we're not actually deploying it to Rinkeby. So what we're going to want to do is we're going to want to uncomment out all of these things. Because all of these things, if you see there's all of these Tellor libraries, you're going to be like, what on earth is this? And this is our sample Tellor. So whenever you're testing your contracts, you probably don't want to figure out and deploy the entire Tellor system. You would have to run a bunch of miners and you would have to figure out how to start up all the IDs and make sure that prices are getting placed in them. For testing purposes, you just want to be able to say, hey, this is the value on the Tellor system, and we'll pretend that there's a Tellor system there. So we wrote for you guys a mock Tellor system that you guys get to use. Has all of the features of Tellor. You can practice some disputes. You can see how your whole system functions on different Tellor pieces, but there's not that whole live mining. You need a network. You can do everything locally. So first thing, of course, I changed the name from sample using Tellor to Unitize. So we're gonna have to change that in 3 places. And then here, so 1, this is the Tellor ID. So this would be like ETH US dollar if you're on mainnet. But we're not on mainnet, so you can just pretend 1 is whatever you want it to be. And then it'll grab the Tellor master address that it wants. So before we migrate, we're gonna have to kick off our development. So in Truffle, every time you do Truffle init, this part's commented out. I don't know why. It makes it harder to run Ganache. So you got to come in here and uncomment that piece out. But we'll go to another server, start Ganache. Ganache is, this is a pretend Ethereum network on my local computer, on my local host. Then we'll come over to this piece and we'll run Truffle migrate. Hopefully I'm making sense. Definitely tell me to slow down or do something if I'm not. So, all right, compiled. That's always good. What? It's a timeout. Did I not save this? Man, I really hope I... Yeah, that's it. If this doesn't work, we're just gonna have to pretend and I'm gonna have to write you guys the tests. It's always dangerous doing live software demos. Okay, there we go. It's migrating. It flashes behind the screen, it's deployed. See, it cost you 0.15 ETH to deploy the Tellor system and our little contract. So cool. And now, so kind of the most important part of like any Solidity development is going to be testing it, because testing these things is awful. So we tried to fix that for you guys. We wrote you guys some tests and we want to teach you guys how to actually use it. So we'll just come in here. This was right here in the GitHub. And we'll come over and we're gonna go to our tests and we're gonna bring up a new file and we're gonna write unitize tests.js. Okay, so first, we are not sample using Tellor. So we're just gonna do Control H, sample using Tellor. We'll change that to unitize. Replace all. Okay, these guys gotta be underscore. Yeah. This is JavaScript testing in the Truffle framework. If you guys aren't familiar with it, it's probably I like it, much easier than like the Solidity testing in the Truffle framework. But anyway, what it's going to do, basically first you're going to import the contracts that you need. And then here's the before each. So this is just deploying the contracts for each test, and it'll run this test as far as update price, but we actually don't need that one. We're going to we'll cut and paste it just to get some things down here. But the way we'll write it completely from scratch and then delete that one. So what's our function? We're going to run check values test. So check value test. The first thing that you're going to want to do, it'll deploy it, but before each it's going to deploy it with ID 1 and a new Tellor master. This thing right here, this submit mining solution, this is going to create a new Tellor solution. So it pretends like there's 5 different miners that submit a solution, and then a new value is mined on the Tellor system. So they're submitting it for ID 1, and this is what they're saying that the value is. So it's 1200. So let's, we can change this. Let's say it's 5,000. They're all going to say it's 5,000. Now we have something to read. And then what we're going to do is we're going to run check values. So we're going to do let my result equal unitize check. Can I name it? Check values. Check values. Okay. Await. Gotta make sure you await. Okay, and then the cool thing, so this will return like the whole transaction IDs because it's not a call function, but if you do .call, now you'll get the piece that comes back, the bool. Because if you don't put that .call, it'll just give you like the whole transaction hash. You have to parse it and everything, which is, you don't want to do. So what we're going to do is assert. And what are we going to assert? We're going to assert that my result is true. Result should be true. Because if you remember, we check if it's greater than 100, and we're inputting the value 5,000, so it should be true. Hopefully you're following with that. Anyway, so now we'll bring up our node and our console, and then we'll just run a full test. Oh, wait, let me comment out this thing, because I didn't build this for this specific test, so I'd rather just not see if it breaks. Let's see, is it humming along? Yep, all right, so we're moving. Unitize.checkValues is not a function. What? Of course it is. Guessing if I take this off, will that work? Does it want me to write methods? It might want me to write methods. Yeah. So, okay. So what this is going to do, check values. Because what we can do is we can print. So wait, the current value. Show you guys. I know this is, and then you're just going to spend the next day trying to figure out how to get your test working. This is Solidity development in a nutshell right here, guys. Man, I swear I had it working. So anyway, might have to Might have to talk with Ronan here about what's up with this. So I'm going to get this working, and I will post the working version in the code for you guys. But anyway, we've been doing this for a while, so I'm not going to force you guys to sit here and listen to me try and debug this, which is going to be a simple solution. So winner to whoever posts the solution first in the chat room while I figure this out. But anyway, thanks everyone for listening. Happy to help anybody build on Tellor, and happy to, talk with you. I think one of the biggest pieces about actually using an Oracle is going to be, do you need an Oracle? Do you need it to be trustless? And what sort of guarantees do you want in there? And just working out kind of that problem statement, because that's going to be one of the biggest pieces of your DApp, especially if you're building anything on DeFi. So just over a half hour. Thanks everyone for listening. And yeah, talk to you guys soon. Bye.